one specific question that you would like to ask about on 8.3? If not, we'll move on. 87. So number 87 says, 87, let's find it there. The fourth root of 81 x to the 12th y to the 16th. And you're supposed to simplify. What does fourth root mean? Nope. Chris, speak. Go.
Raised to the 1/4.
Yes, to the 1/4 power. So 81 x to the 12th y to the 16th, all raised to the.
1/4.
So what do you do with powers of powers? You multiply them. So it's going to be 81 to what power? 1/4. X to the what power?
X to the
12 over 4. We can write it as 12 over 4 first. It's 3, but let's just write it as 12 over 4 for now. And y to the. So let's simplify that. We have 81 to the 1/4, x to the 3rd, y to the. So there's still something we can simplify here. 81 to the 1/4 means the fourth root of 81. You need to know what that is off the top of your head. It is 3. So it's 3x cubed, y to the 4th. All done. You actually use the tree and simplify these. You have to simplify these. So what do we pull out of 16 first? 2 and 8. And what do we factor out of 8? 2 and 4. And then 2 and, oh, sorry. 2 and 8, 2 and 4, 2 and 2. So you can write the cube root of 16 as the cube root of 8 times the cube root of 2. Because, what do you see right here?
3, 2.
There it is, right there. So what's left? There's still another 2.
Yeah.
Okay, so what is the cube root of 8?
2.
2 times 2 times 2 is 8. What's the cube root of 8? 2. So you have 2 cube roots of 2. Why do I put that parentheses around that?
So it doesn't look like 2 thirds.
Yeah.
It doesn't look like 2 cubed, exactly. So now we go over here and we do the same thing. What can we pull out of 54? 3 and 6 and 12? No, 3 and 27. 6 and what? 6 and 9. Okay, that's fine. We can do 6 and 9.
You don't have to.
It's fine, but you don't have to start as long as you keep going.
Yeah.
What's 6? 2 and 3, and this is 3 and 3. So we're looking for triples. Why are we looking for triples? Because it's a cube root. So this turns into 4 times the cube root of 2 times the cube root of 27. What is the cube root of 27?
3.
That is 3. So what do we end up with? Well, 4 times 3 is?
12.
So 12 cube roots of 2. So we have 2 cube roots of 2, and we have 12 cube roots of 2. So how many do we have?
14.
So we have 14 cube roots of 2. Can't add them because it's 81 and 24 are not the same number, right? At least it's cube root, so maybe we can. So we have to break down 81.
3 and 27.
3 and 27, exactly. So that's 15 times the cube root of 27 times the cube root of 3. But what is the cube root of 27? 3. So you have 15 times 3 times the cube root of 3. Plus over here, is there a cubic factor of 24? 2 and 12. Is there?
8 and 3.
8 and 3, exactly. So that would be 4 times the cube root of 8 times the cube root of 3. What is the cube root of 8? 2. So it's 4 times 2 times the cube root of 3. Well, what's 15 times 3? You have 45 cube roots of 3 plus, and how many do you have there? 8 cube roots of 3. So if you have 45 plus 8, what's that? Close.
53, sorry.
53 cube roots of 3. Exactly, because you now have 45 and 8 together turn into 50. We are going to take what we've learned and apply it to multiplying and dividing radical expressions. No new rules are being invented here, Hannah. No new rules. We have 2 things in parentheses here that need to be multiplied together. So what's the basic rule here that we're going to have to follow? Distribute, exactly. Everything in the first set of parentheses has to get multiplied by everything in the second set. What's the square root of 5 times the square root of 6?
Square root of 30.
Yes. The square root of 5 times 1?
Square root of 5.
Root 5. 3 times this. Oh, look. 3 times root 6 and 3 times 3. And that's not, and did I get 3? Exactly. Is there anything there we can combine? What do you think?
Root 30 and root, no.
On the face of it, it doesn't look like we can, right? On the face of it, well, but right now what we're looking at is the mechanism. We're not going to simplify right now, but we're looking at the mechanism. Yes, go ahead.
Could you, no.
We could try a factor tree and try simplifying, but right now we're just doing the mechanism. What about this one right here? What do we multiply first?
7.
Yeah, so 7 root 5, and then 7 what? 7 root 2 minus root what? 15 minus root. We stop there. All we're looking at right now is the mechanism. We can then simplify later, but right now we're just looking at the mechanism. That's it. The rules don't change, but some interesting things happen in certain instances, like this one. What's the square root of 10 times the square root of 10?
10.
That's 10. What's the square root of, oh, that's going to be minus what? Root what?
30.
30. And then what do you have right here?
Plus root 30.
And then you have minus what?
Root 9.
No, minus 3. Minus 3. Hey, what cancels in the middle?
The third.
And then what do you end up with?
10 plus 3, 13.
Oh.
10 minus 3,
7. 10
Oh,
minus
that's
3
awesome.
is
7.
7.
Oh, sorry, I thought you didn't cancel.
No, it's okay. So that's pretty cool. So what does square mean? What does that mean right there?
2 of that.
There's multiplied by itself. Uh-huh. Oh, it's not. I just did the square root in the wrong place. Root what? Root 7 minus 3. So let's do this. What's root 7 times root 7? 7. What's the square root of 2 times the square root of 2? 2. What's the square root of 3 times the square root of 3? Square root of 7 times the square root of 7. What's the square root of a table times the square root of a table? A table, to whatever is underneath. It doesn't matter what it is. The rule doesn't change. So going back here, root 7 times root 7 is 7. And then you get what? Minus 3 root 7. Minus 3 root 7. And then what's the last number? 9. Exactly. Can you simplify this immediately? Yeah, so it's going to be what? 7 minus what?
6.
Root 7, yep. Plus 9. Can we keep going? What's 7 plus 9?
16.
So it's going to be 16 minus 6 root 7. Sometimes the simplification is straightforward, in which case you absolutely need to do it. Absolutely. Yes, go ahead.
Would you put,
Yeah, so you get 25, and then you get plus 5 cube roots of 3 minus 5 cube roots of 3 minus what?
3?
The cube root of? No. The cube root of? 9. What cancels in the middle? What cancels in the middle?
2, 5, 3 root.
Those cancel. So what are you left with? You're left with what? 25 minus the cube root of 9. Another way you could have written that, what is the cube root of 3 written in exponential form?
3 to the 1/3.
3 to the 1/3. And then what's this one in exponential form? When you multiply 3 to the 1/3 times 3 to the 1/3, what do you get?
3.
3 to the 2/3?
Yes. So you could write it as 3 to the 2/3. Either one, that's fine. Either one is fine. Either one is fine. Either one. Yes, Chris?
Square root of 7.
Over.
Square root of 7.
Yeah, if you multiply by root 7 over root 7, this is just what? That is what? 1. Are we changing anything when we multiply by 1? No. So you multiply across, you end up with 3 root 7 over?
1.
No.
7.
7.
Sorry.
No, don't apologize. Something to apologize for. It's 7. Exactly. It's 7. This seems like you've just made it worse, but the added bonus is there's no irrational number in the denominator, and you will be asked to do that sometimes. Not always, sometimes. Sometimes. Someone tell me what I should do on the first one. What's the first step on the first one? No. Radical 5 over radical 5. I understand what you meant.
I'm sorry.
Please don't apologize. There's no need to apologize. So then what does this become? 5 times root 2 times root 5 over what?
5.
Of 5. What cancels immediately here? 5's cancel. Multiply root 2 times root 5, and what do you get?
Root 10.
Root 10. All done. Nice. So this one, some of you did multiply by root 125. I don't generally expect you to multiply big numbers together, so simplify first before you do things. If your choice is go small then big or big then small, what do you do? Small then big. So yes, this is equal to the negative square root of 18 over the square root of what? 125. What do you think we should do first before we rationalize? What should we do first? Yeah, look for square roots. What's 18? Oh, that's the square root of 9 times the square root of 2 over, oh, are there any squares in 125? That's the square root of 25 times the square root of 5.
I thought it was a table.
We're not multiplying here, we're factoring. What is 18, Sarah? 18 is 9 times 2. What is 125? 25 times 5. Why did I pick 25 and 9? Why are those good numbers at this point? Because they are perfect squares, exactly. What is the square root of 9?
3.
So we end up with negative 3 root 2 over 5 root 5. Now what do we multiply the top and bottom by? Just say root 5, root 5. So what do we end up with? Negative 3 root what?
10.
Over.
25.
Done. Done.
Seems about right. You know, we got
So some of you, naturally, what's the first thing most of you tried?
this shirt down.
Root 2 over root 2. If you do this, what do you end up with on top?
3 over 2.
3 root 2. You have to literally write that down. You guys are not writing equal signs. You are putting things like at angles. If you don't, it's really hard to comment on what you're doing, okay? It's the equivalent of not using periods or capital letters in English class, which you would never, ever be able to get away with and pass in English class. Use equal signs, write things carefully. What goes on the denominator here? Where do you multiply this root 2? Everything. What's root 2 times 1? What's root 2 times root 2? You need a plus 2. Oh. Does that help us? Why doesn't that help us right there? What do we still have in the denominator?
Radical.
Still have a radical in the denominator. So we have to find a different form of 1 to multiply by. So some of you, I see, tried something really cool, and you got even closer. You multiplied by, instead, 1 plus root 2 over. I like this idea. This is a great idea, and you're on the right track. You're close. Let's see what happens here. 3 times 1 is 3. 3 times 3 root 2. But what happens on the bottom?
Cancels.
Does not. What's 1 times 1? 1. What's 1 times root 2? Root 2. What's root 2 times 1? Root 2. And what's root 2 times root 2? 2. So what do you end up with? 3 plus 3 root 2 over 3 plus 2 root 2. Can you cancel anything? No, you can't. Because there be plus signs. Can you cancel anything? No. So are we kind of back to where we started? Yes. My hint to you is you were really close right here. So let me start again. 3 over 1 plus root 2. Who wants to guess what the proper thing you need to multiply by is? Anybody?
3 over 3.
1 minus root 2 over 1 minus root 2. When you do these out, look what happens. What's the
radical 2's will cancel.
3 minus 3 root 2 over 1 times 1 is? Then you get minus root 2 plus root 2 minus what? 2. What cancels on the bottom? The root 2's cancel, and what do you end up with? Equals 3 minus 3 root 2 over negative 1. So that's equal to negative 3 plus 3 root 2. You flip the signs. You flip the signs. Did we just get rid of the denominator?
We're so close.
You were so close. So the key thing was this is close and this is, oh, nice. So here's the general rule, everybody. Let's say I gave you 7 over 5 plus the square root of 3. What do you multiply by?
5 minus square root of 3.
Over?
Yeah. It's 5 minus square
Exactly. Then you would do the work. What happens if I gave you 9 over negative 5 minus the square root of 2? What do you multiply by? Negative 5 plus the square root of 2 over negative 5 plus the square root of 2. What's the only thing you change? The sign in the middle. If it's negative, what do you turn it into? Positive. And if it's positive, you turn it into a negative. Exactly. So get back to the board, everybody, and please simplify this one for me. Bye.
5 plus square root 2.
Over.
5 plus square root 2.
Yep. So if you do this out, you end up with 35 plus 7 root 2 plus 3, sorry, 5 root what? I think it's 5 root 3
Yeah,
plus root what?
6.
All over 25 minus 2. Yeah, there you go. Can you simplify anything on top?
Yeah.
No.
No, it can't. So you end up with the same thing over.
We can't